Good day everyone, we are the group 2 and today we will be learning about logarithmic functions through the discussion that I will be doing today. But before that, let us first know what is a logarithmic function. A logarithmic function is the inverse of an exponential function such that a is greater than 0 and a is equal to or not equal to 1. The exponential function y equals a to the power of x is equivalent to x is equal to the logarithm to the base of a of y. Now let us move on to the properties of logarithm. The different properties of logarithm were derived from the different laws of exponents. These properties are needed in simplifying logarithmic expressions. For the different properties, we assume that the value of a is greater than 0 except 1, and m and n are real numbers. There are a total of 8 logarithmic properties, and these are 1. The logarithm of 1 to any base is equal to 0. 2. The logarithm of a to the base a is equal to 1. 3. The logarithm of a to the power of x to the base a is equal to x. 4. The logarithm of a to the base a to the power of x is equal to 1 or x. 5. The logarithm of a product of m and n to the base a is equal to the sum of the logarithms of m and n to the base a. 6. The logarithm of a quotient of m divided by n to the base a is equal to the difference of the logarithm m and n to the base a. 7. The logarithm of a power is described as the equation logarithm to the base a of m to the power of n is equal to n logarithm to the base a of n. And the last one, the logarithm of a root is described by the equation logarithm to the base a of the square root of m is equal to logarithm to the base a of m divided by n. At this point, let us now try to apply these properties in expanding and simplifying logarithmic expressions. Here are some given logarithmic equations for us to express in exponential form. Number 1. Logarithm to the base 6 of 36 is equal to 2. Now logarithm to the base 6 is the base, so we will convert it to 6 squared, and the final answer is 6 squared is equal to 36. Number 2. Logarithm to the base a of m is equal to p. Now logarithm to the base a is the base, so we will change it to a to the power of 0. So the final answer is a to the power of 0 is equal to m. Now here are some given exponential equations. Let us try to express these equations in a logarithmic function. Number 1. 5 squared is equal to 25. The base 5 squared should still remain the same. So the final answer is 2 is equal to the logarithm to the base 5 of 25. Number 2. 4 to the power of negative 3 is equal to 1 over 64. As I said during the previous number, the base 4 to the power of negative 3 should stay the same. So the final answer is negative 3 is equal to the logarithm to the base 4 of 1 over 64. Number 3. 4x minus 12 is equal to 8 squared. The equivalent of exponential equation to logarithmic function is x is equal to the logarithm to the base a of y. So, the power of 2 is rx, then x is ra, and 4x minus 12 is our y. Then we get 2 is equal to the logarithm to the base 8 of 4x minus 12. Now here are some examples in expanding logarithmic equations. Number 1. log to the base 5 of 3x, y, k. We can see a product of a number and variables inside the parentheses. The product rule does not state that there must only be 2 factors inside. There may be many more. Okay, so we'll separate the main log expression as the sum of 4 logs. So, log to the base 5 of 3x yk is equal to log to the base 5 of 3 plus log to the base 5 of x plus log to the base 5 of y plus log to the base 5 of k. Number 2. Log to the base 2 of 7x over y. Inside of the parentheses is a fraction. That means we will first apply the quotient rule. Since the numerator is a product of 77 and xx, we will use the product rule to break it up. So logarithm to the base 2 of 7x over y is equal to logarithm to the base 2 of 7x minus logarithm to the base 2 of y. So it will become logarithm to the base 2 of 7 plus logarithm to the base 2 of x minus logarithm to the base 2 of y. I know it's hard and tiring. Well, it can be frustrating too. But trust me, with all the efforts and practice, it'll be all worth it. And that is it for this video. We hope you learned something from us about logarithmic functions. Thanks for watching and stay safe, everyone.